Hello, folks. Welcome to this first of the tutorials on MSP432E4. And in this tutorial, I'm actually going to talk about getting an example started without using the driver lib. So for this, what I'm going to actually refer to is our GitHub page. So if you go to this GitHub page, you're going to see some examples on the project 0. So I picked up these examples, and so this example is basically the Blinky, and so this one actually uses the driver lib. You can also run this program, and the way I would do this is technically you can import this, but I guess some files for the import are missing, so the project is not able to import it. So here is an example. I would go to project 0, and let me see, where's my project 0? Up in this example, there's project 0, and that's our CCS compiler. And if I look at it, it's basically setting up the two LEDs to blink, using a system delay. And this is actually probably going to blink at about half a second. And the reason being that is whenever you use system delay, it actually runs probably, I think it uses 3 clock cycles for a particular delay, which is approximately about 1 microsecond. That is somewhere in the data sheet that actually mentions that. But so this is the example, and I'm actually going to do an import, and let me just right click on it, build it, and it should build. And if I go right click on it and go to, say, properties, and you should see the products that are using. So it uses the SDK, and obviously if you go to the include, that's where all your source files are, so it's including the source files in there. And you can also look through that by going into hold on, let me go to this PC, go to TI, and that's a repository. Go to sources, and this is the TI folder, followed by so the drivers. We go into the drivers, and these are the files that we are, the include files that we are using. So anyhow, coming back here, and then you can go into the linker, and if you do the search path, and even though all these libraries are included, we are basically only using the driver lib header file, and we're going to only include this particular library, right? And the path is all set. So anyhow, so that's how you are able to use over here. You're including that, and followed by all these syntax for system, setting the system clock frequency, you're enabling the peripherals, defining the type of GPIOs and GPIO pin right. All these are usable. So that's basically an example over there, and you can actually execute that, and you can actually see the LED blinking. So I'm actually going to show you guys the camera. As you can see over here is all my LEDs are off. So what I'm going to do is right click on this, or just go and hit the debug button. You can also do it kind of a debug on different line statements, but for now I'm just going to hit the debug, and I'm going to actually move my camera. So that's my camera. So if I try to play, and you can see that basically, you know, those two LEDs are blinking. So thinking that it is basically saying, you know, then you have the two pins, and each one has a difference of the clock, and so you blink one and then you let the other one blink each time you give the difference in clock, right? So that's basically the simple example of using the driver library. So now what we are going to do is I'm actually going to copy this project, and let me say copy, and then let's paste that. But now I'm actually going to call this project 1, and in this case, and I'm going to copy it in the default location. Or what I should have actually done is I should have cleaned this before. So I'm actually going to clean it. I should have cleaned it before I copied it. So therefore you don't have these files appearing. So let me delete that. So, alright, so we're good. So now I'm also going to rename this as project 1, just to be on the safe side. So I did rename that too. Yeah, it's project 1. And so now what I'm trying to do here is I'm going to actually pull it up from my GitHub, the project 1. But the project 1 is basically what's happening here is, as you can see, that we are not going to use the driver library, and in this case we are trying to also do the initialization of just the one. You can also include the other, but again, you know, setting up the clock, enabling the clock to the port, and then trying to give it an arbitrary delay. So this, the only way you can do delay here is, you know, kind of waste some time using the for loop. So what I'm going to do here is I'm going to copy this guy over here, come back to my project 1, and starting from that location I'm going to paste this. We're good to go. And so what we need to do is just right click on this and rebuild this, and there you can see it's actually rebuilt, and again it doesn't have any errors. So yeah, so this one, as you can see, is occupying about, this is the space, the total number of actual memory. So if I go in here, let's do the rebuild of that, and there you can see over here in terms of memory allocation, that's about approximately 3 times, but you know, still what is going to happen here is you know, using the library, and that will be the difference of using the library versus not using the library. So if I actually come in here, right click on it, and let's say I want to debug this. If this one occurs, you want to say no. You don't want to take any settings from the previous ones. So now the debugging is happening. The programming / debugging is the same. So when I hit the run button, so now you can see that's the only LED that we turned on, and then we have a loop there for the delay. So that's where it is. And if you want to change this into bit 0, then you can set this to bit 0, come back here, bit 0, and so on. So that's actually without using the library. The next example that I wanted to show is this one here, which is on project 2, where we also use a button, right? So now also let me get back to this. The most important thing over here is you can right click on it, go to properties, and even though you're using other libraries or whatever it is, you can actually delete this. In my project 1, if I even delete that and apply, so I'm not using libraries, so you right click on it and rebuild it, and you can see that there is still no errors because no library function is used, right? And so that's what the difference is. In the previous case was 3000 something, now you're using about 1100. So that's the difference. So I'm going to right click on this and say again copy it, and then I'm going to paste it, and here again what I want to call this, I want to call it project 2, get rid of the CCS2, thinks it's a duplicate file name, so it's appending number 2 there, and I copy it, and again what I should have done is removed these files related to project 1. Okay, and let me just check here, and here everything is project 0, just these are all project 1, so it's fine. Okay, so going back to this project 2, what we want to do is also include a bunch of buttons. So if I go here, go into project 2, so this is almost, I'm using all these things, but here is again an interrupt is enabled for the buttons. So we're using the two LEDs in port N, N0, N1, and the two buttons in port J. So because of that, and then I simply am using this function, which is enabling the interrupt, because this involves again another 3 registers to manipulate. But other than that, most of this code is almost 95%, I would assume, or 96% of the code is based off or it's not based on tribal level. So I'm going to actually copy this and go to this particular project 2 and get this whole thing, Control V, and let's save this, and let's right click on it. I actually made it in project 1. So I should do let's be there alone, project 2. I'm gonna make this once related to project 2 and come back here, and this is I guess this is what I did. So this is, I should have named this project 2, and going into project 2, let's take the file from here and paste the new code, which is again using the buttons. So there are 2 buttons, and 2 of these buttons will raise an interrupt, and as you can see I have, I'm actually also here you can see I'm actually setting it to a falling edge, and the reason why we are actually setting that to a falling edge, if you go down here, look at the manual, down here, these examples, but in hardware kits, and go to your launchpad, go to the launchpad, this guy over here, okay, so I'm actually going to go down to this section. This is my okay, that's where the keys are. So down here, if you look at it, it is actually connected to the ground. So every time you hit this switch, it's actually going to go down, and we're going to also enable the pull-up resistance. So I think that's somewhere here, pulling up the pull-up resistance. Key init. Let's go to the key init. That's the direction. There you go. So that's where you actually pull up the internal resistance. So the value is always going to be high. If you hit the button, it's going to go low. So that's why we want to always keep it as on the falling edge. So coming back to this scenario, let's right click on it because we already deleted the thing. Let's rebuild the project and see if there's any errors. There's no errors, everything is good. And cancel. Yeah, so it actually does pick up from the previous cases. And that's that. And now we can see that the board has no activity. And we are going to make this run, and as you run, so going back to this guy over here just a little bit, yeah, you can see. And what we are going to do here is so these LEDs are there, so I'm actually going to press this button. These are user buttons. I know which button is used. There you go. So every time I press this button, so the LED turns on. There you go, and the LED turns off once I take it. So that's basically what happens here. And this one here is the one if every time I press this button over here, and it's just going to just read the instantaneous status. So one is actually using as a push button, the other one is used as a toggle button. So that's the scenario. Again, this is a combination of both using most of these using registers, code that is in most of it using registers, and the other code that is actually used only a couple of codes that are using the library. So, and what you would find is commonly that we use most of the code using the library, and the other way around, one of few codes it's simpler to just set the bit using that, and more specifically just we use bit banding to set the those particular register values. Alright, so this is a quick run through. In the next one we will see more examples on how to use codes that are related to your design assignment. Thank you.